Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? Yesterday I think we were discuss about the nomenclature system of disubstituted benzene derivatives. And before that we already discussed the nomenclature system of monosubstituted benzene, and today we are going to discuss the rest of the derivatives, how to give a name of that compound. As we know that nomenclature system means what? The systematic way of giving the name of the organic chemistry is known as a nomenclature system, and there are the two systems generally used for naming the organic compound, which are newly synthesized in a different research laboratories. And let us begin with the polysubstituted derivatives. Means polysubstituted benzene derivatives, we can call it here polysubstituted benzene derivatives. Polysubstituted benzene derivatives. The name itself suggests that poly means many and substituted means substituent present on benzene ring. And how do you name these derivatives? That we are going to discuss here. If more than two substituents or groups are attached to the benzene ring, only numbering system is used to indicate their relative position. Let us see here. I am representing one structure. You can observe the structure carefully. One Br here, another Br here, and one more Br at this position. Now more than two substituents if present on the benzene ring, so it is termed as polysubstituted benzene. So it is one of the structure. Now when such kind of the polysubstituted benzene, then you must follow the numbering system, because in case of the disubstituted benzene derivative, maybe same substituent or the different substituent, disubstituted I am talking about, then there is a numbering system, as well as whenever there is a isomeric forms are different isomeric form, generally 3 isomeric forms are obtained in a disubstituted benzene, like as a ortho, meta and the para. If they are present at ortho position with respect to or with relative to the main substituent, other substituent may be present at ortho, meta or para, depending upon, because the monosubstituted benzene ring, there are, as we know that there are 6 hydrogen atoms present on the benzene ring, and one of the hydrogen atom, all the hydrogen atoms are equivalent in nature, and therefore the replacement of one hydrogen atom, it gives rise to only one kind of the monosubstituted derivatives. But when monosubstituted derivatives form and there is a replacement of other 5 hydrogen atom, that 5 hydrogen atom are non-equivalent in nature, means they are not the same, they are the different one, such as 2 are ortho, 2 are meta, and 1 is a para, and such kind of the differentiation is generated due to the presence of one substituent, and depending upon the relative position of that other substituent present with respect to the main substituent are ortho, meta, and para. So let's see here, but here more than 2 substituents are present on the benzene ring, that is called as polysubstituted benzene derivatives. Now look at 3 substituents are there. Here you should follow the numbering, you must follow the numbering system. So numbering system, how do you give the number? So there are the various possibilities are there, but most probable possibility you have to number in a such way that the other substituent should get the lowest number. That numbering you should follow here. Suppose one bromine atom is here. Can you start the numbering from this bromine atom? No. Do you start the numbering from this bromine atom? That is also is not correct one. Can you start the numbering from this side? Yes. But the motion of that numbering, whether from left hand side or right hand side, yes, you must number from right hand side. If you give the numbering from the left hand side, that is not the correct way, that you should remember here. So the numbering of that compound, I am showing here the probable numbering system. One can start the numbering from here 1, 2, 3, 4, 5, 6, or other possibility 1, 2, 3, 4, 5 and 6. But if you give the numbering from this either left hand side or the right hand side numbering system you follow, which is absolutely wrong. Remember here, if you start the numbering from here on left hand side or right hand side, that numbering system also is completely wrong. So which is right then? If you start the numbering from this side, but if you follow the left hand, if you travel from left hand side, that is not also the correct one. The correct way of numbering system must be like this: 1, 2, 3, 4, 5 and 6. Observe the structure carefully. After looking this structure, you will say here, look at the bromine atom, where that bromine atoms are present here. One which is present at 1 position, 2 position and the 4 position, and therefore you can write down here 1, then 2 and 4 dash. How many are there? Total are 3, and therefore you can call it as a tri-bromine is there, so tri-bromo, and this is a benzene moiety, so followed the word is a benzene. So this is the correct way of naming. This is the IUPAC name of this polysubstituted benzene derivative. That is the name which we have given over here. Or let us see here one more structure I am representing here. Look at the main substituent which I am written here this one, then let me draw one, let me attach one Br here, another Br here, one Br here. Look at this structure. This is also the polysubstituted benzene derivatives. Means more than two atoms attached to the benzene ring, then that type of the benzene are generally termed as polysubstituted benzene derivatives. So this is a polysubstituted. Now the numbering, from here you can start the numbering. Look at from here, either this side or that side, this molecule is just like as a symmetrical molecule. You cannot start the numbering from here, you cannot start the numbering from here, you cannot start the numbering from here. Also, only you can start the numbering from here where the amino group is attached to the benzene moiety or benzene ring. So that amino group looks or it seems to be a main substituent, and therefore numbering should be starting, one number should be starting from that carbon atom. Then now you can follow the path either left hand side or the right hand side, or clockwise manner or anti-clockwise manner, because there are two same identical substituent present on both the ortho side with respect to that amino group, and therefore you can number either right hand side or the left hand side. So you can follow that one. So number 1, give the number 1, 2, 3, 4, 5 and 6. So this is the numbering system. Or either you can give the number from this side, left hand side, 1, 2, 3. Whatever the identical bromine atoms are there, they present on the same positions with respect to that amino group, and therefore look at here at 2 position, 1 bromine here, at 4 position, 2nd bromine present, at 6 position, 3rd bromine present, and there are 3, so you can call it as a tri, and then bromo, tribromoaniline. Tribromoaniline, that is a name. Aniline is a general, what we can call it as a name given to that moiety, and therefore it is known as a 2,4,6 tribromoaniline. That is a IUPAC name of this compound. Now let me draw another example, which is a polysubstituted here, 1 OH. Here is a benzene ring. Then here I am attaching this kind of the group. Here this is a NO2. And now this is the same case whatever we have just now seen in this structure. So look at here. So I can give the number from here, 1, 2, 3, 4, 5 and 6. The IUPAC name of this compound, the nitro group, they are present at 2. Then another nitro group which is present at 4 position. One more nitrogen atom which is present at 6 position. So 2, 6, 2, 4, 6. Then dash trinitrophenol. This is known as a trinitrophenol. Phenol is a one, we can call it as a, this moiety is there, and therefore it is called as a 2,4,6 trinitrophenol. This compound is known by their common name, and common name of this compound is a what is it is? The name of this compound is a picric acid. Do you heard this? Picric acid. It is a the strength of that picric acid is approximately similar to the hydrochloric acid HCl. HCl the strength and picric acid nearly is the same, and therefore it is called as a picric acid. 2,4,6 trianitrophenol. Why that picric acid is more acidic than simple phenol? So you might be in your previous classes you already know the theory behind it, why phenols are acidic in nature, because while studying as a reactivity of the organic molecule, at that time there are, I think, 6 factors which are responsible for which affect the reactivity of the organic molecules. These are the electronic factors. For example, first one, inductive effect. Do you heard this word? Yes, I know you heard, you know these effects: inductive effect, resonance effect, then hyperconjugative effect, hydrogen bonding, tautomerism, steric effect. These are the structural effects which modifies the reactivity of the organic molecule. Depending upon these factors, they can modify the reactivity of the organic compound. Let's see over here why that picric acid is more acidic in nature, because here the OH group, that hydrogen atom is responsible, or it can determine the reactivity of that particular organic compound. The other part, don't think about the other part only. After the dissociation there is a formation of the carbanion, and once the formation of the anion over there, and that anion is well stabilized due to the resonance effect, and due to that reason that picric acid is more acidic than the simple phenol. That we know that phenol generally is acidic in nature, and aliphatic, that alcohols, even though both are having as a hydroxyl group, but in one case in a phenolic OH are the acidic in nature, whereas alcohols are the neutral in nature. The reason behind it, then you dissociate that acid, and when that H plus form, and there is a conjugate base form, and that conjugate base, if it is stabilized due to the effect which I altered just now short while ago, inductive effect, resonance effect, steric effect, hyperconjugation, hydrogen bonding, tautomerism, they can modify the reactivity of the organic molecule. And therefore here in case of the phenol, after the dissociation, conjugate base is formed. That conjugate base is well stabilized due to the resonance, and that's why phenol are acidic in nature. But in case of the alcohol, after the dissociation, whatever carbanion is, whatever the anions are formed, conjugate base are formed, that conjugate base is destabilized due to the plus I effect, and or plus I effect or sp3 hybridization, the carbon atom which is attached to the immediately after that oxygen atom, and that destabilize that carbanion, and due to that reason it will pick up the proton back, and undissociated alcohols are formed, and therefore it is neutral in nature. But in case of the phenol, the negative charge which is developed on that oxygen atom, it is moving or delocalization takes place, and for movement of that one cycle, when it is resting on its original position, it took long time, and therefore that H plus is shows as a acidic property. And now one more structure which I am going to draw over here. You can remember this is one of the structure CH3, then NO2, here O2N, then NO2. The name of this compound, once again look at here, 1, 2, 3, 4, 5 and 6 polysubstituted benzene, and therefore the name of this compound is 2,4,6 trinitrotoluene, trinitrotoluene, TNT, or the common name of this compound is what we can call it as a TNT, short form is a TNT, trinitrotoluene. It is a very explosive and which is generally used in the for explosion purpose. In this way we have seen the general introduction of that polynuclear and the heteronuclear aromatic compound. We just talking about the aromatic compound. The simplest aromatic compound is the benzene, and that the discussion we are discussing so far. So before the structure, we have seen some of the nomenclature system of that benzene. Now moving toward the or coming back to our structure of benzene, and that even though benzene was discovered long back in 1825 by Michael Faraday, this is a scientist name who discovered the structure of the benzene and its properties were studied well. The problem of its structure baffled or the puzzled generation of chemists of 19th and the 20th century. In 1834, Mitscherlich of Berlin University obtained benzene by heating benzoic acid with lime. Very simple procedure for getting the benzene in the laboratory. They have obtained benzene starting with that benzoic acid with lime calcium oxide heated. What they got? They got the benzene, and the side product is a calcium carbonate. That is the compound they form. Here is a benzene, and the byproduct is formed as a calcium carbonate. This is a benzoic acid. Now we know the structure of benzoic acid, but long back the scientists didn't know the structure of the benzoic acid, but that benzoic acid, when treated with the lime calcium oxide heated, they had obtained benzene, and the byproduct is a calcium carbonate. And after getting calcium carbonate over here, you can see here calcium carbonate, and main product is a benzene. But the structure of benzene puzzled at that time of the organic chemist. At that time, benzoic acid was easily isolated or extracted from the trees, but the structure of benzene puzzled early organic chemists, and from different experimentation they observed different facts about the benzene. Then first one is a molecular formula. Benzene was obtained first by compromising the coal gas and was shown to possess formula C6H6. That is a molecular formula they got. And though benzene has unsaturation, it did not undergo the characteristic addition reaction like alkene and alkyne. See, though benzene has unsaturation. Do you know unsaturation and the saturation? Once again, the organic experiment is during performing organic qualitative analysis. There is a one test to identify whether the given compound is saturated or the unsaturated. By using the chemical method, one can easily determine or one can easily identify whether the given compound is a saturated or the unsaturated. There are two reagents which gives quick information related to the saturation and the unsaturation. One reagent, that is a Br2 in presence of CCl4. Everybody, you know that bromine is a brown in color. When it added across in a test tube, if you shake it, if the color of that bromine is changed, it means that there is something is happening, means reaction is taking place, and that brown color, original brown color of the bromine atom get disappear, and then the conclusion or the interference, you can infer that the given compound is unsaturated in nature. If there is no change in color, you can infer that the given compound is saturated in nature. This is one of the tests. Another test that is called as a Beer test, and the reagent used as a potassium permanganate, which is also pink in color. When it is added in that solution of that mixture, suppose that solution becomes as a colorless or some other colors, it clearly indicates that compound, the given compound is unsaturation in nature. So that are the simple tests you already perform in your organic qualitative analysis. But here unsaturation, theoretically to identify whether the given organic compound is saturated or the unsaturated is very easy. Just observe the structure carefully. If there is carbon carbon double bond or multiple bond, say triple bonds are present, that compound are unsaturated compound, and those organic compound containing single bond, then that organic compound are generally termed as saturated. So this is a benzene, and the one characteristic feature of the unsaturated compound, they readily undergoes addition reaction. If the symmetrical molecule is there, it will end up with single product, but unsymmetrical alkene or unsaturated compound, it is end up with the more than two products. And if more than two products are there, among that two products, one is a major and another one is a minor. And therefore, in a minor and the major, that is a stereoselective compounds, generally we are getting over here. And that is a characteristic of unsaturated compound. And what they found, benzene also has a carbon carbon double bond present in that benzene, but it does not shows the characteristic feature test of that addition reaction similar to the alkene and the alkyne. And this is the question, very big question before that scientists, and that's why the structure of that benzene puzzle with that organic chemist. So when benzene treated with Br2 in presence of CCl4, there will be a no reaction, and the same reaction, let us see here. Here C6H6 treated with Br2, let us say CCl4 carbon tetrachloride, no addition reaction. But if you C2H4, that is ethylene, that will be treated with, let us see here, this is a benzene, but here C2H4 plus Br2 treated with CCl4, once again carbon tetrachloride, it is a brown in color, this is a ethylene or you can say ethene, and you will end up with C2H4 Br2 plus C2H4, that is a dibromo ethane, that is a product form. How do you conclusion? Benzene cannot undergo addition reaction like alkenes. Conclusion, what conclusion you can draw here, what inferred you can draw here? Benzene cannot undergo addition reaction like alkene and alkyne. So that, and the next one is a benzene yield only one monosubstituted product, and whatever the remaining points, I think that remaining point we will discuss in our next lecture. Now let us wrap up the today's lecture here. Thank you. Have a nice day.